All right, today we're going to continue learning about completing the square. I've given each of you this document or paper. We're going to do the evens together, and then we'll allow you to do the odds for homework. So let's get into it. Let's continue to talk about completing the square. When we started talking about this the other day, we talked about completing the square. And why is it called completing the square? Because we're looking for the perfect square trinomial. The perfect square trinomial. For example, like we had 9x squared minus 16. What was that one called? That was the difference of squares, DOS, right? But now we're looking for the perfect square trinomials. For example, x squared plus 8x plus 16. Is that a perfect square trinomial? Absolutely. We start by looking at both ends, and we see perfect squares there, a 1 and a 16. And then we take the square roots of those. Square root of 1 is 1. Square root of 16 is 4. And we multiply them. 1 times 4 is 4. And then we double it to get 8. Okay, so yes, this is a perfect square trinomial. And that's what we're talking about when we see or when we deal with these completing the square. Now, all the ones that we deal with today are going to, like the ones we dealt with the other day, are going to have a leading coefficient of 1. We're not going to deal with a leading coefficient other than 1 for a couple days yet. All right, I want to be really good when the leading coefficient is 1, and then we'll deal with the other because there's a slight adjustment. Okay, now as we found those two square roots and we multiplied them, then we doubled it. Yes. So let's start by looking at what would have to be the constant at the end here for this to be a perfect square trinomial. 36. Excellent. C would have to be 36. How did you do that? Well, we went 12 divided by 2 is 6, and then 6 squared is 36. Does that make sense? Good. So let's look at the next one. What would C need to be for this to be a perfect square trinomial? What would it need to be, and how did you come up with it? Don't everybody talk at once. Let me go over the last one again because maybe you were sleeping. I took the middle number, or we took the middle number and divided it by 2. And then we squared it. Okay. Mr. Sable. 6.5. 169. C must be 169. How did he get that? 26 divided by 2 is 13. 13 squared is 169. That's the process. How you determine what that perfect square at the end has to be. Okay? Oh boy. Now, everyone I've given to you this point, that middle number's been even. What happens when it's odd? Well, watch this. 5 divided by 2. Okay, 2.5, but I don't like those decimals. Watch this. Can I just, whatever 5 divided by 2 is, 2.5, I would then square it, right? Well, if I square this, what's 5 squared? 25. What's 2 squared? Isn't that easier than 2.5 squared? So C will be 25 over 4. Let's try one more. What do we do to the middle number? Divide it by 2. So 13 divided by 2. But that doesn't go in evenly, does it? See, this is why I like fractions, because, yes, I can put it in there. It's going to be 6.5. But, I mean, 13 over 2, that's a real fraction, right? Then what do I have to do to it? Square it. What's 13 squared? And what's 2 squared? Boom, there it is. C equals 169 over 4. Now, you're not going to have a lot of them that have odd numbers in the middle, but when you are, my suggestion to you would be to do this. Just leave it as a fraction. Okay? Here's why. Watch this. Here's why. I want to go back to these two. You know, we're creating this perfect square trinomial, y squared minus 5y plus 25 over 4, so that we can factor it quickly. But it's got a fraction in it. How am I going to factor it quickly? Well, we already know what the factored term looks like. This is going to be x minus 5 halves quantity squared. That's all it's going to be. And we already know that because we showed it right here. Cool? Just like this one is going to be x plus 13 quantity squared. What's number 2 going to be? X minus 6 quantity squared. There's the 6, there's the minus, right? So let's look at this last one, number 4, or number 8, sorry. What's this one going to look like factored? What's this one going to look like factored? It's x squared minus 13x plus 169 over 4. What's it going to look like factored? Zyler? What number did I use in the other 3? What number did I use here in number 6? That one, right? What number did I use in number 4? What number did I use in number 2? What's it going to be? Blessing?
X minus 13 over 2 quantity.
That's it. Okay. I know that's a little difficult for you because you see the fractions and you all pucker up. All right. Now, that's just finding the square to make it a perfect square trinomial. These last ones, we actually need to complete the square. As a refresher, I'm going to do one and you're going to do the rest. Okay? I'm going to do one, you're going to do the rest. Remember, the first thing I do is I rewrite my problem, p squared minus 16p, and I leave a big space. Plus 60 equals 0. In that space, I put a parenthesis. Now, what do I need to add and subtract to this? Blessing? 4? No. 64. How do you get 64? Negative 16 divided by 2 is negative 8. I have to square that to get 64. So I'm going to add 64, and I'm going to subtract 64. Why do I have to add and subtract? Because I really can't, I'm not adding anything. If I add 64 and I take it away, Sable gave me $20 the other day, right? Oh, he didn't. He took it right back. He didn't give me jack squat, right? Okay. Now that we have it sitting like this portion can be factored. What's it going to be factored? P minus 8, quantity squared. Now, combine those like terms. Negative 64 plus 60 is a negative 4. This is in vertex form, which is what we wanted. Cool? Let's try the next one. Let's try number 12. I'll give you a minute. Try number 12. All right, let's look at number 12. Rewrite the problem. X squared plus 8x, leave a space, plus 7 equals 0. Put a parenthesis halfway through the space around the first half. Now I got to decide what I'm adding and subtracting. So I take my middle term, 8, divided by 2. 8 divided by 2 is 4. 4 squared is 16. So I'm going to add 16, subtract 16. This quadratic in the middle is now a perfect square trinomial, which means I can factor it really quickly to be x plus 4 quantity squared. And I know it's 4 because that's what I found right here. Then I combine my like terms at the end, which is negative 16 plus 7, and that is a negative 9, and that equals 0. That is in vertex form. My vertex is negative 4, negative 9. Yes, ma'am. Always put the positive inside the parentheses. Remember when we were talking last week how in order for it to be a perfect square trinomial, our last term or our constant must be positive because we're multiplying the same number times itself. So if it's negative times a negative, it's positive. It's a positive times a positive, it's positive. That's a great question. Let's try one more together. Number 14. I'll give you a minute. And let's do number 14. Again, I've given you all ones that don't have a leading coefficient. That makes it a little bit easier here. So I rewrite my problem, r squared minus 16r, leave a space, minus 57 equals 0. Put a parenthesis around because this is what I have my parenthesis around. That's where I want my perfect square trinomial to be. I take my middle term and I divide it by 2. Negative 16. Oops, that was ugly. Negative 16 divided by 2 is a negative 8. Negative 8 squared is 64. So I'm going to add 64 and subtract 64. That way I did nothing. Okay. Factor the perfect square trinomial now. Well, that's really easy because here's my term that I'm looking for. So it's going to be x minus 8 quantity squared. Combine my like terms at the end. So that's a what? A 1, oops, not plus, but minus 121 equals 0. And what's my vertex going to be then? It'll be a positive 8 and a negative 21, 121. Remember, we always have to take the opposite of what's on the inside. Okay? Number 16, I'm just going to go right into it because we're about out of time. Watch the process. You can just sit back and relax and you can copy down for a second when I'm done. Okay? V squared plus 16v space plus 39 equals 0. Space and parenthesis. 16 divided by 2 is 8. 8 squared is 64. So I'm going to add 64 and subtract 64. This perfect square trinomial is easy to factor. It is now x plus 8 quantity squared. And then combine my like terms at the end, which is those two constants, which is a negative 25, and that equals 0. My vertex then is negative 8, negative 25. Questions, comments, concerns? Yes, ma'am.
If you use like whenever you do like the second part of it after you like find the like 64 and then you like put the like x plus like I put like the v and the on, is that right or do I need to
Oh no, yeah, I keep putting in x, don't I? I apologize. Yes, this should be a v. I guess the last one should have been on r, not an x. Yes, I apologize. Habit, hard habit to break. You're a hard habit to break. All right. Your homework is the rest of them, including 18 and 20. Good luck. Have a great day.